I'll change it later. All right, so you could sketch this graph in your notes. It is in your textbook, but I want you to kind of sketch it. I'm going to read the passage that's in the textbook. I'm not going to write it down. I don't expect you to write it down. If you want to read it out of your textbook. We're on page 14. This is example 1 for 1.2. Okay, so this is example 1. And in your textbook it says that Lyme disease is a bacterial infection transmitted to humans by ticks. When the infected tick bites a human, the probability of transmission is a function of time since the tick attached itself to the skin. Ugh, that's gross. During the first 24 hours, the probability is 0%. During the next 3 24-hour periods, the rate of change in the probability is always positive, but is much greater in the middle than the other 2 periods. After 96 hours, the probability is almost 100%. Sketch the graph, and that's what I have written here that represents that. So the first thing we want to do is identify the x and y axes. Now, remember, Mr. Adams says the x-axis is the independent variable, and you would say, well, how do I know something's an independent variable? Well, you know it's an independent variable because it's easier to figure out what depends on what. So in this scenario, the probability depends on time. So the probability as a percentage of a human getting infected increases over time. So that means that the probability will be our y-axis because that's the dependent variable. And like I said, time on almost, I can't think of a situation where time wasn't the x-axis. And then we have a domain and range that we deal with. Domain means what? All possible x's. What does the range mean? All possible y's. So in this scenario, we're talking about a domain from 0 to 96 hours, or in this case, 120 hours, and a range of 0 to 100% chance of getting Lyme disease. Does that make sense? Now the domain and range mean something because we're putting it in context of stuff. So what they want us to do is identify the intervals. So let's talk about that for a second. What is it that you notice? So let's start with the intervals. So I'm going to start. Let's do it like this. See this right here? What does this mean? Nothing? How about I'll help you guys out. I think if I do the first one, it'll make sense. So from 0 to 24 hours. So we're going to call this the domain. And then the range, remember that the range is the percentage or probability. So the range is the percentage of catching Lyme disease. That's the probability. It's 0, right? So in the first 24 hours, there is 0% chance of getting Lyme disease. So if I got a tick, I go to the beach. Mr. Adams goes to the beach a lot. I go to Waco Beach. I'm walking through the trails. A tick jumps off a tree. Aha, I got you, Mr. Adams. If I get rid of that tick in the first 24 hours, I have 0% chance of getting Lyme disease. What's that? Right. Yeah. Oh, that's what you meant? Okay. I get you now. All right. So now, where is the next change on the graph? So what we're going to do is we're going to look at the graph from 24 to 48. I'm going in this direction, right? So let's write that down. From 24 to 48, what's my range? Well, my lower bound is what? For the y. So now we're doing the y values, right, from here to here. Oops, I don't want to do that. What was I doing? So I want to go from here to here. So I'm going up. But my y value at this point is what? 0, right? That's 0. Good job. So 0 is less than y is less than or greater, or is less than or equal to. Now, what about here? At x equals 48, what's this value? In fact, I am going to write this down. So from here, we've got 0, comma 24. That's this point right here. And then this point right here, it looks like, oh, I did it backwards. You guys got to pay attention and tell me what I'm doing. It's technically 24, comma 0, right? It's x, comma y. And then this point would be what then? I'll do the first number, 48, comma, what's the y value at that point? 10, good. And so since I'm only focusing on the y values for the range, it goes from 0 to 10. So after 48 hours, what does that mean? At the 48-hour mark, I have a 10% chance of getting Lyme disease. Yeah, 10% is better than 100%, right? And it increases over time. So at 36 hours, which is right in the middle, I probably have what? Not 50%, half of 10, which would be 5. So let's do the visual. So 36 would be here. About here is the percentage, and that's halfway to 10, so it'd probably be 5%. Okay, that's what this graph means. That's what this graph is telling us. Let's move on to the next interval. So we've got a change from x equals 48 all the way up here to this point. And this point is, what's the x value of that point? No, it's 72. 75 is the y value, right? Maybe that's what you were saying. So let's do the x's. So from 48 to 72 hours. I probably should stress this. This is hours after the tick latches on. The range is the probability of catching, let's write that out too, catching, they say infected, but I like to use words you guys use, catching Lyme disease. Yes. Yeah, 72, comma 75. So remember, the domain is all the x values. So on all these things, we're looking at the x's and the y's. So the point on the graph gives us an x and a y. And the domain are all the possible x's, right? And the range is all the possible y's. So the y values that correspond to this, what's the y value when x equals 48? 10. What's the y value when x equals 72? 75. So what this is saying is that at 72 hours, the end of the third day of being of a tick latching onto you, you have a 75% chance of getting Lyme disease if the tick has Lyme disease. Okay? You have a 75% chance. All right, let's move on to the next one. The next point here, this one here, occurs at 96 hours. And maybe I should write that out, 96 hours, comma. Boy, that's pretty close. I don't know what I would call that. Is that 97? 96? I don't know what I would call that. I would probably say it's about 97%. So we'll say that's a 97% chance. So we focus on the x's, right? What's the lower bound? And what I'm really doing is
And let me go back and label some of these things. From here to here is this stuff. Let me change the color. This section from here to here is this stuff. This section from here to here is this stuff. Okay? And now we're moving on to this section from here to here. And that's going to be the stuff we're going to write down now. Okay? So what are the x values for that? Well, it goes from 72 to 96. So from 72 hours, the next 24-hour period, to 96. Our y values that correspond to those, our range for that interval, goes from 75 to about 97. So at the end of the fourth day, 96 hours, you have a 97% chance of getting Lyme disease from a tick if it has Lyme disease. This is funny because I just went to St. Joe last weekend and went to the beach. And it was a friend of mine, and as we kind of walked through this trail in the woods, and as we got to the road, because he lives by the beach, we stopped, and he goes, let's check ourselves for ticks. And so I was like, I guess, whatever, David, it's a little weird, but this is why, right? Because if we get one and we get rid of it right away, we're good. But if I go home and I don't notice it, blah, 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 not good, okay? I don't know if you saw this graph or not. It's just funny. It made me think of it. All right, last little bit there. We're going to go from 96 to 120 hours. So from 96 to 120 hours, my corresponding y values are, well, they start at 97%. And in the textbook, it said almost 100%. Oh, no, it says, yeah, it says almost 100%. So you could write 100%. I'll probably be more inclined to put 99.9%. That's the scientist in me. Okay. Okay, so that's what we're going to do, right? In the real world, there's data. How did they come up with these lines? Basically, just like what I said before. They went out and they said, how long was the tick in you? They took 100 people and they said, okay, we pulled the tick out. When did you get bit by the tick? Well, I was at the beach at this time. They measured the time backwards. They plot the data. They get a graph like this, and then they have an idea. Do you know that when you are 2 years old and you go to your 2-year-old annual checkup at the doctor's office, they can predict your height by doubling how tall you are when you're 2, and it's within an inch. It's amazing. All 4 of my children, when I took them for their 2-year-old annual checkup, they measured my kids, and they said, oh, this kid will be about 6 feet tall. He was. This kid will be 6'1". He was. This kid will be 5'9". He was. So it's amazing to me how they know that stuff. And I asked the doctor, I said, how did you know? He said, well, we just collect the data over basically decades. And he said, we figured out that when a kid's 2 years old, they're about exactly 1/2 of what their actual height as an adult will be.